I'd like to do a quick review of quadratic functions. You probably know that a quadratic function is one whose highest term has a squared variable or has an exponent of 2. Our general form, you may also hear this called standard form, is f of x is equal to ax squared plus bx plus c. So quadratic function has a few important properties. The first thing is that it has a vertex, and the vertex x coordinate is going to be at negative b over 2a. The y coordinate, by the way, you find by figuring out that x coordinate first and then plugging it back in to the original equation. It also will have an axis of symmetry. We'll do an example with that in just a minute. And that's going to be an invisible line with the equation x equals negative b over 2a. The last thing is that you probably know that the graph of a quadratic function is called a parabola. And the parabola opens up if your a is greater than 0 if it's positive. In that case, your vertex will be a minimum point. It will be the minimum, actually. It'll be a local minimum and an absolute minimum. And if it opens down if your a value, the coefficient of the x squared, is negative. In that case, your vertex is going to be a maximum, both a local and an absolute maximum. We're going to do a quadratic function example. I just asked you to find a whole bunch of stuff. Go ahead and pause, try this on your own. So first thing I need to do is figure out what is my a, b, and c. So my a is the coefficient of the x squared, it's negative 3. My b is the coefficient of the x, which is 6. And my c is just going to be the constant, which is 1. So to find out my vertex, the first thing I need to do is find the x coordinate of my vertex, which is going to be negative b over 2a, which gives me negative 6 over 2 times negative 3, which is another negative 6. So the x coordinate of my vertex is 1. So far I have that. I find my y coordinate by doing f of 1. And I'm just going to go ahead and substitute that into that equation. When I do that, hopefully if I do everything right, I should get 4. So that's my vertex. Actually, the axis of symmetry is going to be the same as the x coordinate of the vertex. It has the same formula, so I don't even need to do any work. I know that it's an imaginary line at x equals 1. For part C, I asked you whether the graph opens up or down. Hopefully you remembered that if the coefficient of your x squared is negative, it opens down. And then for part D, I asked you to find f of 3. That one's a little bit more complicated, but it's stuff that you did previously when you first did functions. So hopefully, as long as you didn't make any algebra mistakes, hopefully it wasn't too bad. And you should end up getting negative 27 plus 18 plus 1, which, if you do everything right, gives you negative 8. For part E and F, these ones are actually a little bit easier if I do them once I have the graph. So I'm going to go ahead and skip ahead to G. I'm going to do the graph of this one. On my graph, I already know a few things. The first thing I know is my vertex. It's at 1, 4. By the way, I drew this this grid knowing that the vertex is at 1, 4 and the graph opens down. That's always a good way to start graphing things. So that's my vertex. The other thing I know is that my axis of symmetry is this imaginary line that goes through x equals 1. That's going to help me a little bit. One other thing I didn't actually mention, but it's a nice thing to know, and that is that the y-intercept of a quadratic function in standard form is going to be at 0, c. So in this case, it's at 0, 1. That's helpful to know. So we're actually going to draw that also. And the other thing that I can use to help me is this axis of symmetry. I know that since I have a point at 0, 1, I'm also going to have a point on the exact opposite side of that axis of symmetry at 2, 1. The other point that I found is I actually know what f of 3 is. I found that f of 3 is -8. That means that the point 3, -8 is also on the graph. So I'm going to draw that one too. I believe it's right here. So once I have that, I can do an equivalent point on the opposite side of that axis of symmetry. And that means that there's going to be a point at -1, -8. So now that I have all of these, I have enough points to graph my quadratic. I think having 3 is probably a good amount, one of them being the vertex. So it's going to kind of look like this. Hopefully yours is a little better if you're doing it on paper. And like that. Now, mine's not perfect, but it should be a nice parabola. So now that I have this, I can figure out a few things. So I am going to, first of all, my domain. Actually, a little hint. Any quadratic that does not have a domain restriction has a domain of all real numbers. For my range, I can see based on my graph that, this should be curved up here by the way, it doesn't look quite perfect, but I can see that my highest point is at y equals 4. However, everything else below that is okay. So my range is going to be, you can either write it as, you can write it in many different ways. I'll show you a bunch. So you can write it as x such that x is less than or equal to 4. You can write it in interval notation, which would be -infinity to 4. Just make sure if you do this in interval notation that the -infinity has a parenthesis, not a bracket, and that the 4 has a bracket, and also that the -infinity comes first. We always go in order with interval notation. So then letter F, the intervals of increasing and decreasing, it is increasing up until when x is equal to 1. And after that, it's going to be, so this is my increasing, and after that, it'll be decreasing the entire time. So the last thing I want to talk about is the vertex form of a parabola. It looks like this. You can get to it by completing the square, or if you're lucky, actually the graph will already be given to you in vertex form. And the reason we call it vertex form is because the vertex is that point hk. You might actually recognize that this is a quadratic function of, it's something that has a parent function of y equals x squared, and it has a horizontal shift of h to the right and a vertical shift of k up, and then it has a vertical stretch of a. It's the same idea as what you did with that section. So I'm going to give you an example where you need to write the equation. You don't have to graph unless you want to. For this example, we are going to be writing the equation of a quadratic function that has a y-intercept of -3 and a vertex of 1, -5. If I get something like this, I usually like to draw like a 10-second graph just to make sure I know what it's going to look like. That often helps me know if it's opening up or down, because there's a lot of places where you can make mistakes on this. So I know that I have the vertex at 1, -5. I know that my y-intercept is at -3. It's going to look something like this. So that'll just kind of help you out a little bit, knowing what it might look, knowing what the graph might look like. We can already tell that the a is going to be positive, so that's something helpful to know. For this equation, we're going to use that function above. I know right away that I'm going to have an x minus 1 squared in my parenthesis, and then it's going to be not plus, it's going to be -5, because my h is equal to 1 and my k is equal to -5. So I got the first step of that. The other thing that I need to do is I need to use the point that I have. I know that the point 0, -3 is on the graph. So now I can find a by using that point. So that's going to be -3 equals a times 0 minus 1 squared minus 5. I get -3 is equal to a minus 5. That gives me a equals 2. So my final equation, I'm not done yet, by the way. Don't just write the a and be done with it. A lot of people do that and they get the problem wrong. Final equation is f of x equals 2 times x minus 1 squared minus 5.